Hello, good morning, good afternoon, and welcome to the latest in the Vordel webinar series. Today's topic covers a very hot topic that we've had a lot of interest in. One of the heaviest, if I can say that word, most heavily attended events in the history of the webinar series here today. It's the OAuth enterprise patterns. And before we kick off, I'd just like to alert you to some of the housekeeping rules today. All attendees are on mute, except for obviously the presenters. We would invite you to submit questions throughout the webinar via the chat windows, and we will collate these questions and then feed them to the presenters for a Q&A session which will take place at the end of the webinar. There are some dial-in numbers there if you're having difficulties accessing the webinar for audio. However, we will be posting the webinar to our website after the call, after the webinar, and you'll be able to download it on demand at your leisure later. So, without any further ado, I would like to introduce you to Nazir Mohammed from our partner firm SENA, a leading SI in North America. Nazir will introduce himself and then hand you over to Josh from Vordel. Nazir.
Hi, my name is Nazir Mohammed. I lead the Vordel practice at SENA. aurionPro SENA is a preferred professional services provider for Vordel. SENA has been delivering Vordel-based solutions for financial, healthcare, and retail sectors, working very closely with Vordel. Apart from Vordel, aurionPro SENA has over 12 years of global experience delivering solutions around identity and access management, portal, content management, and so on. And it is also two-time Titan Award winner at Oracle Open World. Today in this webinar, I will be going through some of the enterprise OAuth use cases, demonstrating the value add of OAuth in an enterprise. With that, now I hand it over to Josh.
Thanks, Nasir. My name is Josh Bregman. I'm the Chief Solutions Architect here at Vordel. My job at Vordel is to work with our customers in implementing and designing solutions around the Vordel API server. And over the past year, we spent a lot of time working with a number of customers, particularly around API management. And with that, there's been a lot of interest in OAuth and OAuth 2.0. So the agenda for today's session is first, I'll be giving an overview of OAuth 2.0, the specification, and some of the common enterprise deployment patterns. I'm then going to turn it over to Nasir, and Nasir is going to take you through some more detailed real-life customer use cases of enterprises using the Vordel API server and OAuth 2.0 to deliver solutions. And then finally, I'll give you a little bit of an overview of the API service capabilities for OAuth 2.0 and close with some recommendations around how you can get started with OAuth 2.0 in your enterprise. And then finally, we'll close up with some Q&A. So, OAuth 2.0 101, what is it? After a long time and many draft revisions, OAuth 2.0 is now an approved spec, IETF RFC 6749. It's actually two specifications. There's a bearer token usage was split out as a separate RFC, 6750. The bearer token RFC demonstrates one of the interesting aspects of OAuth 2.0. It has a number of extension points. Anyone in the community can add their own token types, and it can still be a quote-unquote OAuth request. This flexibility is one of the biggest challenges for enterprises. OAuth 2.0 doesn't have the same rigor as the WS star standards. I think the basic analogy of WS security is to SOAP as OAuth is to REST. It holds. But you have to understand that OAuth 2.0 has been driven by large service providers, not typically by enterprise software companies. So even some of the key supporters, like Facebook and Salesforce, have their own variations. So it's not perfect, but there really isn't anything better. There are a number of use cases that we'll discuss in this webinar, but the canonical OAuth 2.0 use case is that I, as a resource owner, want to share some resources, in this case pictures, from one site, which is the resource server, to another site, which is here the client. So we've all actually seen this OAuth flow in action. In the example, this is one of my favorite OAuth real-life scenarios. I want to share some pictures that I have in Facebook in JibJab. So JibJab, for those that aren't familiar, it lets you create animated cartoons, and then you can put other people's faces on the characters. So in this scenario, from inside of JibJab, I get prompted to log in with Facebook. You get this pop-up that says, JibJab would like to access your basic info, your email, your birthday, your photos, etc. In OAuth, these are called scopes. You can actually, if you look at the URL here, see the scope being requested. If I'm okay with JibJab accessing this information, then I click the login with Facebook. At this point, JibJab can retrieve an OAuth token that it can present back to the Facebook API to get my pictures. Though Facebook doesn't, in the standard, the token that is issued also has a refresh token, and that can be used to refresh the access token at a later date without prompting the end user for credentials. The notion of scopes and refresh tokens are key elements of OAuth 2.0, and good reasons to use OAuth instead of a simple transport level security like HTTP Basic or two-way SSL. So what are the challenges in the enterprise? When discussing OAuth 2.0 with enterprise customers, they're broadly familiar with this use case that I described. We've all seen it. Their first question is, how does that apply to the enterprise? The use case I described is a consumer-oriented use case, where the resource is available online to grant access to the resources. Enterprises typically have B2B scenarios, where the resource owner is not available to grant access, or as in many B2B scenarios, not even relevant to the transaction. In an extranet scenario, authentication may be more about integrating with existing employee identity management systems or through existing federated identity systems like SAML or WS Federation. Fortunately, OAuth 2.0 does cover these more enterprise scenarios through different grant types. A grant type is essentially the credential information that is being exchanged for the OAuth token. The core specification defines several different grant types, as well as the ability to extend for additional grant types. These other, less often discussed aspects of OAuth can provide rich solutions for enterprises who are in the process of transitioning to REST-based architecture, but also want to leverage their existing identity access management or federation investments. Also, OAuth is not limited to REST. For example, Salesforce.com allows consumers to use OAuth tokens for both SOAP and REST API calls. Before we get into some of the more interesting enterprise scenarios, I want to cover the basics of the three-legged OAuth flow. Before the flow even begins, the client has been registered with the OAuth server. The result of this registration is the client now has a set of credentials that they can present to the authorization server to identify themselves. Typically, or classically, this is a client ID and client secret, but we've done implementations where we simply use two-way SSL or even a JSON web token, JWT or JOT, to identify the client. The resource owner navigates to the client site and acts as a resource that needs an OAuth token. The client redirects the user browser to the authorization server. The redirect includes the client credentials and the permissions, the scopes that I mentioned, that are requesting on the user's behalf. The user has to now log into the authorization server. The authentication mechanism is not specified. So one nice thing about the Vordel API server is that it has native and direct integration with a number of identity and access management solutions, including Oracle Access Manager, CA SiteMinder, Tivoli, RSA, OpenSSO, as well as LDAP, relational databases, or Active Directory. Once the user is authenticated, they are presented with the form to grant the client application the requested permissions. The user selects the permissions that they want to grant and clicks OK. The authorization server redirects back to the client with an authorization code. The authorization code is presented back to the token server, which is a different endpoint on the OAuth server, and they get an access token for the user. With this access token in hand, the client can now request a resource protected by OAuth. The convention is to pass the access token in the HTTP authorization header, but many implementations pass it in the query string or a different HTTP header. As we'll see in some of the other scenarios, you can pass the OAuth token in a SOAP header. This is actually what Salesforce.com does. Regardless of how the token is passed, it arrives at the resource server. The resource server needs to validate the OAuth token, identify the requester, and ensure that the token has the required scope. Though this part is not specified, a typical enterprise scenario would be to have the resource server make an API call back to the authorization server and get this information about the token. In the Vordel API server implementation, we call this our token info API. In our implementation, the token info can be configured to return additional information about the user, including user attributes or an SSO token. The resource server can simply pass the SSO token that's returned to the actual API. This allows for simple brokering between OAuth and existing single sign-on implementation. So if we look at the three-legged variations, the flow that I just described in detail was the authorization code grant type. It works for clients that have the ability to keep information confidential, which are basically server-side applications. The client application may periodically call back to the authorization server with a refresh token and get a fresh access token for the user. There's a special grant type for JavaScript-only application called the implicit grant type. In this flow, the authorization server skips the step of returning authorization code and just returns the access token. Through some JavaScript magic, the access token is retrieved from the URL, and then it can be used to make API calls. Similar to the three-legged flows, before the client application has been issued a client has been issued a set of credentials. Actually, I would say that in that scenario, the client is issued a set of credentials when it can be trusted. For example, some customers view mobile devices as untrustable. They don't want to embed any client credentials inside of mobile applications, but they already have an existing relationship with the resource owner. The two-legged flow all follow from the same pattern. A request comes in with some combination of client and end-user credentials, and the response is an OAuth access token. The client credentials are validated against the client registry. User credentials are validated against the enterprise's existing identity management repositories. If everything checks out, then an access token is returned. The rest of the flow is the same as the three-legged token. The access token is passed, validated, possibly wrapped, swapped for an enterprise token, and then passed to the actual API. There are a number of variations of the two-legged pattern. The resource owner's grant type is very similar to the classic web single sign-on interaction. The user sends in their username and password, and return gets a token. The client credentials grant type is only passing the client credentials. This is a common flow for B2B, especially if we think of the client credentials being something like an X509 certificate or a JSON web token. This is also a popular pattern for application-to-application calls inside of an enterprise. It's a lot simpler to integrate a wide range of application stacks with an OAuth token than it is with SAML and WS Trust. This is why sometimes jokingly I call an OAuth server a REST-TS, a REST binding for traditional, as an alternative to traditional heavyweight WS Trust STS. Finally, the resource owner grant type can also take the client credentials. This is an interesting scenario if there needs to be authorization of the client and the end user's access to the API. With the two-legged flows, we can also use a number of tokens as credentials. As I mentioned before, the OAuth specification has a notion of an extension called bearer tokens. This is the ability to add tokens to an OAuth request, either to identify the client or as a grant type. This is a standard way to swap an existing token for an OAuth token. The most interesting of these extensions is the JWT bearer token. JSON web token, or JOT as it's called, is to REST as SAML is to SOAP. For people who are not familiar with JWT, I'd recommend taking a look at it. JWT makes a really nice token for web or web services, and it's much more compact than SAML. It's also a key part of the OpenID Connect specification, which I like to think of as OAuth 2.1 or 3.0. Now notice I didn't say that an OAuth access token is to REST as SAML is to SOAP. It's not. You know, the OAuth 2.0 spec doesn't formally say what an access token is. It's essentially just an opaque identifier. JWT and OpenID Connect solve this problem by issuing a JWT with the access token that can then be signed and validated by others. In the meantime, for enterprises that have an existing SAML-based federation, the SAML bearer token allows for the swapping of SAML assertions for OAuth tokens. This is valuable for companies making the transition from SOAP to REST, but they don't want to set up any new agreements or keys. As I mentioned, OAuth 2.0 is extensible, and we have used this flexibility to swap single sign-on tokens for OAuth tokens in a two-legged flow as well. This profile simplifies the client integration with OAuth over the three-legged flow. This is a good way to enable applications inside the enterprise to call OAuth protected APIs. So in summary, the three-legged flow allows for end users to grant specific permissions, scopes, to third-party applications. This is the classic OAuth use case. The code grant works for confidential clients, server-side apps, and the implicit works for public clients, client-side / JavaScript applications. For most enterprises, I suspect the two-legged flows are much more interesting. They represent bridges from existing enterprise technologies like single sign-on or SAML federation to OAuth. One last point about client credentials. The simplest form of client credentials, client ID, client secret, is not the only form of client credentials. Client can use tokens like SAML or JWT. Clients can be authenticated by X509 certificate. OAuth's flexibility should make it very attractive for these enterprise use cases as well as consumer use cases as well. And now, Hugh, I'm going to throw it back to you for an audience poll.
Thanks very much, Josh. And folks, before we go over to Nazir to look at some of the particular use cases that are both three and two-legged, we'd like to just gain from you some understanding of what is driving the OAuth initiative within your enterprises. So we have here a list of some of the typical drivers, and I'd like you all to just pop in your thoughts, put your votes in, and we'll collate that information and present it back to you so you get a feeling for what are the number 1, 2, 3, 4, and 5 drivers. So about 40% of you have voted, so I'd like to encourage the rest of you to click on that button somewhere. Okay, there's kind of two running neck and neck, one getting out more in front now. Okay, I think we'll close the poll there, and we'll present the results momentarily. And we'll share the results. So hopefully you can see on your screens there that REST API for general computing is out in front with almost a third of you, bang on a third of you, saying that's the main driver for your own OAuth initiative, but followed very closely by two others. Very interestingly, mobile API, so obviously the need for you to have mobile applications out there promoting and various services you have is key, and also then the concept of B2B federation and the use of OAuth for that. And unsurprisingly, I guess social media following up last from an enterprise perspective, not such a key issue. Okay, we'll now go over to Nazir. If we can present the slides, Josh, for Nazir, we'll hide the poll and move on to slide 14. And Nazir, if you'd like to now take over. Thank you very much.
Thank you. Right. So this is an enterprise three-legged OAuth use case. We'll start with this. Here in this use case, we have a major financial institution and its third party. The third party is developing an app for its customers to visualize their financial profile based on their financial data. The challenge implementing this app is accessing data from the financial institution on behalf of the end user, obviously without the need for storing the end user's credentials on the third-party servers, implying the need for some sort of federation token-based solution for addressing authentication and establishing the trust between the financial institution and the third party. Apart from the authentication and establishing trust, authorization is another critical requirement in this use case. The authorization question at hand is, what is the third-party app authorized to access on behalf of the user? If you further analyze this, the authorization requirement is actually twofold. Firstly, out of all the exposed services by the financial institution, what are the services that are authorized for this specific third party? Bear in mind that there could be more than one third party and additional exposed services that are not intended for this particular third party. The second fold of the authorization query is out of these authorized set of services which are exposed for the third party, which subset of services is granted by the end user for the third party to access on behalf of the end user. So for example, in this financial profile app, the customer can say, I want to expose my bank accounts but not my investment holdings. So at runtime, the financial institution has to make a grant to deny decision for this two-fold authorization query. These requirements, are typically implemented using role-based access control model or an attribute-based access control model with its own policy, decision point, enforcement point, and their, the authorization modules. These authorization modules, in most cases, tends to become very complex to implement. OAuth 2.0 provides a simple solution for this authorization problem, leveraging the concept of scopes. Another aspect of this use case is establishing the trust. OAuth specifications does not define the specific of trust establishment protocol. Vordel API server provides an out-of-box application that can be used for registering the third parties with the API server, thereby establishing the trust. So to see the solution, I will go to the next slide. In the next slide, there's this administration time registration of the third party. So the third party app registers itself with the financial institution's API server as a trusted client. Once this trust is established, third party app can be accessed by the financial institution's customers. So now at runtime, the flow would be as follows. The customer tries to access the financial profile app. App checks to see if an OAuth token exists for this customer on its server. As the customer is accessing this app for the very first time, there will be no token. The customer gets redirected to the financial institution's API server. API server authenticates the customer and presents the dialog box. Now, this dialog box has a list of scopes that are presented to this customer. The scope is what is allowed access to the third party, basically. So the API server presents all the services that are allowed access to the third party, and now the customer can further select or further restrict access to the services which the customer wants the third party to access on behalf of the customer. So the customer checks in the checkboxes based on its discretion and submits the checkbox. The dialog box. API server generates gets the request, and it generates an authorization code for the customer, and it is provided to the third party via redirect. The third party app now gets the authorization code and requests for an access token from the API server, presenting the authorization code. API server gives the access token because there is trust established between the third party and the API. The API server gives the access token back. One important thing to note here is the authorization code was sent to the customer and not really the access code or the access token. That's because we can't really trust the user agent of the customer, right? It could be the browser or the mobile device. So the authorization code gets passed to the profile app, and the financial profile app requests directly interacting with the API server and requesting for an access token. Once the access token is received by the third-party app, the access token is now mapped to the customer, and this mapping is persisted on the third party. Thereby, now this third party can request resources on behalf of the customer as per the need. And whenever the financial app requests for services from the financial institution, the financial institution's API server will authorize, first of all, asserts the token, checks the scope, and authorizes the request and provides the services to the third party. That completes the end-to-end flow of the three-legged enterprise OAuth use case. In this use case, we see that the third party maintains its own identity store, and the financial institution has its own identity store. And the trust was established using the API server's OAuth client registration application, right? For scenarios where the trust already exists, for example, based on SAML, we have the next use case, which is more of a B2B use case. Yeah, so B2B, yeah. In this use case, we have a big pharmaceutical company and a R&D third party. R&D third party is a service provider, and it provides research and development data to the researchers of the pharmaceutical company. In this use case, we have the SAML-based trust already in place for the third party to identify the user. Now, to provide these services, third party needs to make multiple callbacks into the pharmaceutical company. And the pharmaceutical company, to service those callbacks, has enabled a B2B gateway that validates the SAML token and allows access to the needed resources. With this infrastructure in place, now the pharmaceutical company wants to restrict access to these callback services. Restrict access based on the researcher's privileges. That means apart from the SAML token assertion at the B2B gateway, they also need to check authorizations. And while implementing authorization, authorization-based solution using SAML, it realizes that SAML attribute or claim-based authorization implementation becomes very complicated. Here is where OAuth comes into picture. OAuth provides a simple solution for authorization. We have seen that in the last use case. Apart from that, SAML token processing is a resource-intensive operation which is performed on each and every request coming into the server. OAuth tokens are simple and are considered lightweight when compared to SAML token. On the next slide, we will see this solution. With the OAuth solution, the flow will be as follows. The researcher of the pharmaceutical company tries to access the third-party services from the pharmaceutical portal server. Now, the pharmaceutical portal server requests a SAML token from the API server. API server generates a SAML assertion for the researcher and also generates an OAuth token. While generating the OAuth token, it evaluates allowed scopes for the researcher, right? That's where it restricts the access. At this point, the API server can evaluate the applicable scopes based on the user attributes, or it can integrate with fine-grained entitlement solutions like OES, Oracle Entitlement Server, or Axiomatics, where these entitlement servers can return the scopes as exactional obligations as a response to an authorization query. So, at the end, the scopes would be retrieved, and the OAuth token would be generated. The trick in here is the generated OAuth token is actually embedded into the SAML token and is sent over to the third-party service provider. The third party has a SAML module that asserts the token and identifies the user. This time, when coming back to callback services, along with the third party comes not with the SAML token but with the OAuth token. API server on the pharmaceutical company authenticates and authorizes the access based on the corresponding scope of the token. Accordingly, the requested resources are allowed to the third party, and the third party does its data analytics and sends the final response back to the researcher. That's the end-to-end flow for a B2B SAML-based integration. This architecture leverages SAML infrastructure for establishing trust between pharmaceutical company and the third party. And more importantly, acts as a conduit to pass the OAuth token in a secure fashion. It also leverages lightweight OAuth token and its powerful feature of scopes for restricting access. With that, we will go to the third use case, which is the mobile use case. This is the most common enterprise OAuth use case, and it's a most simple OAuth implementation. Here in this use case, a major health insurance provider likes to provide its services on a mobile device, specifically using native apps. Native apps built on top of platforms like iOS and Android. Most of the needed backend services already exist and are currently serviced by the web browser. There are few implementation differences between a traditional web-based application and a mobile native application when it comes to authentication, storage of cookies, and the request response data formats, and that becomes a challenge. And also, along with that differences, the organization also needs to address integrating these mobile apps with the existing authentication and single sign-on solution. Here is where Vordel API server comes into picture, providing a complete support for OAuth 2.0. More importantly, mobile platform compliant data transformations and integration with third-party single sign-on providers. OAuth is the preferred protocol for authentication for native apps. Mobile platforms like iOS and Android support OAuth protocol out of the box. So going to the next slide, we'll see how the solution works end to end. So here, when the user taps on the native app on the mobile device, native app checks the user profile store of the mobile device for an OAuth token for that particular application. If this is the first time the user is accessing the app, there will be no token, and the user will be prompted with the user ID password. User enters the user ID and password. Once it enters and it hits the submit button, OAuth token request is sent to the AZ server using the resource owner password grant type. At this point, API server integrates with the single sign-on solution for authenticating the user. The single sign-on solution authenticates the user and sends back the single sign-on token. It could be the SM token for SiteMinder, or OB oblique token for OAM, or OAM token for OAM. Right? API server now generates the OAuth token and swaps the single sign-on token with the OAuth token and sends it back to the application. The token is stored by the native app using the mobile platform's OAuth module and will be used for subsequent request to the API server. Where, in the subsequent request, the API server can validate the token, check for the expiry time, check for the scopes to make sure that the requested resource is allowed for the user. And once the assertion is successful, provides the access to the requested resource. Also, if the user tries to access the native app again, let's say after the expiry time of the access token, the OAuth refresh token can be used to get the new access token to continue access to the application without the need for providing the user ID and password again from the native app. So that ends the end-to-end flow of the OAuth for mobile native apps use case. One other item, yeah.
Go ahead, Nazir. Sorry.
There was like one other item which I wanted to talk about, which is the refresh token, the revoke token part. API server provides a revoke token endpoint. The revoke token endpoint is used to revoke access on demand by an administrator. For example, the health insurance company decides to revoke, let's say, Nasir's access to the usage of mobile app. It can do so by invoking the revoke token endpoint. This protocol is not defined in OAuth 2.0 and is added by Vordel to address this type of scenarios. With that, I end my use cases and for a quick poll.
Thanks very much, Nazir. Sorry for cutting across you just at the end of your slide there, but as I said, this will be on demand, so if anybody missed that while they were voting, you'll be able to listen to it later. So this is the way we can test were you listening for the last 30 minutes, where we've asked you to input what you think is the most applicable pattern for your enterprise based on the 2- and 3-legged model deployment patterns we've shown. So feel free to vote there. I'll give you a moment to think about it. You've also been very good in submitting questions, so we'll be collating those and getting to those in the Q&A at the end. So another moment while you vote. Okay, I think we can launch the results there. And you should see on your screens momentarily the results. So out in front, the 3-leg authorization grant seems to be the most applicable pattern for your enterprises. So that's quite interesting information for us and obviously for yourselves. And there's a commonality, I guess, in an approach across the board there, followed closely, well, in second and third place, very close to each other, is a 2-legged model. So there's some consistency there across all of you, which is an interesting characteristic. So you're not alone, in other words, out there. So we'll hide those results and move to the next part of the webinar, which is, again, presented by Josh, which looks at some of the ways you can deploy OAuth using the Vordel API server. So Josh, take it away.
Yeah, thanks, Hugh. So I really like this picture of the API server sort of surrounding the API. This is what we see customers who are in the process of enabling their existing enterprise infrastructure. It's what they're doing for their APIs. The API server provides this sort of new, I'll say, identity perimeter. You see all different client types coming into the enterprise, web applications, mobile, cloud-based, partner apps. And you can really see how all the flexibility, the different grant types that we talked about here for OAuth can be really useful in building out this type of perimeter. Once authenticated and authorized to access the API, it's common for the request to be transformed from REST to SOAP or from one version of the API to another. This request is dispatched to the services, whether those services are running on-premise or up in the cloud. The inbuilt token swapping STS capabilities of the API server are really useful in brokering the user identity to these various disparate endpoints. All of the access to the APIs are monitored and controlled via the administrative interfaces of the API server. Limits for APIs can be set by client, client type, network segment, by user, etc. The API server has robust auditing, reporting, and diagnostic tooling to simplify the operational aspects of running this type of infrastructure. APIs can be developed, debugged, and versioned simply and easily inside of the design time tooling of the Vordel API server. It's simple to learn and doesn't require exhaustive, XSLT or WS policy knowledge to build a REST API. Here you can see that the Vordel API server has simple filters for each of the OAuth grant types. You can easily add new grant types by dragging and dropping filters on top of the policy. No coding is required. The Vordel API server has over 190 out-of-the-box filters and integrates with a number of leading identity and access management solutions such as CA SiteMinder, Oracle Access Manager, Tivoli, RSA, etc. The API server has robust JSON, JWT, REST security features, and can very simply and easily convert XML to JSON. Integrating the Vordel API server OAuth solution into your enterprise is very simple and straightforward. A lot of the discussion around OAuth is about authentication of various credential types and the issuing of tokens, but from my perspective, the most powerful aspect of OAuth has a very simple and powerful notion of authorization called scopes, which we've discussed in various use cases here. A list of scopes for the enterprise are defined here inside of the Policy Studio. Scopes are essentially a claims-based model. When the client requests a token, it makes the request with a set of scopes. Either the user or the system can allow or deny the scopes. So the server issues a token with a subset of those scopes. The notion implied by the specification is that access to each of the resources is granted if the token has required scopes. It's a very simple and powerful model. It obviously can be extended with more fine-grained access control. For example, the API server has integration with Oracle Entitlement Server, Axiomatics, or a straight XAML PDP. One underlooked value of scope model for enterprise is that users can effectively administer their own permissions, dramatically reducing administrative overhead. Here we see a view of the client registry for the Vordel API server. Authorized administrators can configure the client information required for the OAuth protocol. The administrator can also define the scopes that the application is allowed to request. The client registry, besides having a UI, can be integrated through a set of REST APIs. It's worth noting that this webinar is about OAuth, but the client registry of the API server can also manage API keys for more of an Amazon Web Services style security model. It can manage client certificates used for signing for JWT or SAML. The API server has a unified view of client credentials regardless of the type of protocol. Finally, you can see the Vordel Manager's Traffic Monitor. This tool makes troubleshooting and analyzing API usage very simple. From this web-based console, an operator can filter messages by client, service, path, method, return code, etc. For an individual transaction, the operator can see the messages in and out, can step through each filter's execution. Here we're seeing some of the details of the three-legged OAuth flow. So before we get to questions, I just want to close with a few recommendations based upon our experience working with customers around OAuth. So establish some enterprise-wide OAuth deployment patterns. You need to think about what brand types will you support, how will you identify clients, how will the OAuth resource server and authorization server be physically deployed, co-located or distributed, what scopes will you define, how will you authenticate resource owners. Think about it as more than just three-legged OAuth. OAuth and related standards, JWT and Jose, which is the signing and encryption, are the keys for REST security. So get started. Even if you're looking at a B2B or SAML scenarios were mentioned, look for opportunities to consolidate existing SOAP STS to new SOAP and REST STS powered by OAuth. Leverage your existing security relationships. If you have a lot of SAML or X509 certificate infrastructure in place, look at leveraging that. You don't need to create API keys or client ID and client secrets to use OAuth. Use an STS for flexibility and compatibility to backend systems. A very common pattern, which Nasir explained in detail, is using OAuth to front or broker to something else that is protecting existing APIs, like single sign-on or Kerberos. You can use the out-of-the-box capabilities of the API server to issue these tokens without passwords, or have the server make calls to existing STS for the tokens to map. Again, look for consolidation opportunities here. Is the enterprise IAM still required in the architecture? Besides consolidating existing WS Trust-based STS, can you use OAuth as a step towards breaking your dependency on your existing identity management solution? I obviously think you can. I mean, we've talked about how to wrap what's there in OAuth, but as more and more applications move to client-side applications, AJAX types application, there's less and less value in sort of web single sign-on. You're basically obtaining access to a single HTML page that then makes a bunch of REST API calls. It's the API calls here that are key. OAuth and JWT can provide a unified path forward for web and web services. And keep it simple. Always a good idea in any project. Hopefully from looking at the various scenarios and customer examples, something jumps out as low-hanging fruit for your enterprise. That first OAuth project can be as simple as resource owner's grant type, using a username and password to authenticate against LDAP or Active Directory. There's a ton of flexibility in the specification in general, and this can be daunting. And to be honest, may at first blush may make the specification not seem enterprise enough. We have many enterprise customers that are using OAuth 2.0 today to deliver real solutions. If you're waiting for WS star level specification interop, you're going to be waiting a long time. In the meantime, the CEO wants access to everything on his or her mobile phone or iPad. My suggestion is to seize the opportunity and look at OAuth 2.0. With that, Hugh, I'll throw it back to you.
Great, thanks very much, Josh. And before we go to the Q&A session, which I know you're all keen to get to, we have just a little promotion for the next webinar in our series, which you'll see there on the next slide, which is in co-presentation with Eve Mahler and Ed King from Vordel. That's December 6th, and you should be able to register for that very shortly from the Vordel website. This webinar is a follow-on really from this one and looks very much at the challenges of IAM in the enterprise with the consumerization of IT and the concept of the open web needing zero trust to solve the tough security, identity, and agility problems you face. So be sure to register for that webinar, which will be next month. And lastly, I'd like to promote the fact that you can get a free trial of the Vordel API server if you go to the Vordel website and register for it there. So after the webinar, we'll be encouraging you to go to the website to download the API server and get to practice some of the implementation patterns you've seen here today. So without further ado, we'll jump to the questions, and we'll try to cover as many as we can, but we've got about 10 minutes left, and we will be archiving the entire webinar for on-demand later, so some of you have asked that. So if your question isn't answered or you don't have time to hear anymore, you can drop off, but the questions will be answered either on the webinar or we'll get back to you by email. And every single question will be answered by either method. So Josh, one for you first. Does OAuth help with session management, and can I use OAuth to replace my web access management platform?
Yeah, Hugh, that's a good question. I think we mentioned some of these details in the webinar. It doesn't directly do sessioning today, but if we look at how people are using web single sign-on, I mean, those products have an incredibly rich set of capabilities, but most people are using it for very basic things. So I think the short answer is yes. You can start at looking at things like JWT, which has more of a semantics and layering on things like idle timeouts and max timeouts. I mean, more and more, like I said, we're seeing a real convergence between web and web service technologies, and the existing access management technologies are providing less and less value. So we've been working with a number of customers who are using OAuth as the foundation of if not full-on eliminating, but certainly reducing the sort of dependency on those web access management solutions.
Okay, thank you. And Nazir, this may be one for you from the field in terms of what you see. In my current B2B integrations, we use certificate-based authentication. So this questioner is wondering, can they use their existing certificate infrastructure with OAuth?
Yes, surely we can use the existing certificate infrastructure. The correct grant type for that would be the client code grant type, like how Josh was mentioning in the webinar. The client code could be anything. It could be a certificate, X509 certificate, and API server authenticates the X509 certificate and creates extracts the user ID and generates an OAuth token out of it. There's also another way we can integrate with the X509 certificates using JWT token, wherein the JWT could, the content could be signed by the certificate, and the signature would be checked by the API server, and thereby authenticating again by the X509 certificate. Also, in one of the investment firm, as part of BYOD, all the mobile devices were procured with a certificate, and the certificate was sent for authentication to the API server. API server authenticates, and at that as a return type can send the OAuth token back. So the answer is yes, we can definitely use the X509.
Thanks very much. And here's another one. In the scope, it relates to one of your slides, Josh. In the scope field, we saw friends_birthday as the scope for JibJab. So the question is, what defines the attributes that form part of that scope? Is it a predefined agreement between JibJab and Facebook?
Yeah, that's a really good question. So one of the things that people like about REST APIs in general is there's just a lot less specification around them. So sort of the question you're asking there is that if I'm writing an application that wants to consume the Facebook APIs, how do I know the scopes that they define? And the short answer is today, it's just in regular doc. just up on their website, and we can post the link, you can see the list of all the sort of scopes that are defined there. So there's no, in Facebook's implementation, there's no type binding there. Now, I've alluded to another specification, which is called, we talked about OpenID Connect. There's another part of OAuth called User Managed Access. And User Managed Access starts to talk about some more formal structures where, as an endpoint, I can advertise in a formal way what the scopes are and what they mean and the pictures associated and things like that. But I guess what I would say is, like a lot of things in REST today, it's more sort of ad hoc or sort of by convention.
Okay, very good. Here's another one. We're still in the early stages of implementing SAML. Is SAML going to be replaced by some OAuth-based scheme? I'm guessing that's one for you, Josh, as well, just looking at it.
Yeah, so one of the things that I mentioned in the webinar is that there's this thing called JWT, the JSON Web Token, which is the easy way to think about it is it's like SAML. It's like an actual token, but it's JSON instead of it being XML, and it's compact, and it has the standard things you'd think you'd see in a SAML assertion, like the issuer and the principal and some audience and expiration times and things like that. And there is a mapping, back and forth between SAML and JWT. I don't think that SAML is going to go away, and we talked about how you can swap SAML assertions for OAuth just as you can for JWT. But I think it's certainly worth understanding that SAML as a sort of federation is an older technology, and the more modern sort of federations are likely to be based upon lighter weight things like OAuth and JWT.
Okay, great. And here's a question more for Nazir from SENA. Nazir, the question is, we're an Oracle Access Manager shop, and how can I use OAuth with Oracle Access Manager?
Yeah, that's a good question. We can definitely use OAM and OAuth together. As and when you have more OAuth-enabled applications getting developed in an organization and existing OAM infrastructure, and let's take a case where you have a browser in which you have an OAM cookie already existing because the existing single sign-on system in place, and the user is now trying to access an OAuth-enabled application, right? So when the call comes in to provide the single sign-on experience, when the call comes in to access the OAuth application, API server can actually create an OAuth token on behalf of the assertion of the OAM cookie. So API server can assert the OAM cookie talking to the OAM access server, and upon the successful assertion can create an OAuth token. And that token could be passed back to the client. That way, the user gets a single sign-on, experience. There are a few things which we need to consider while implementing the use case, like session management is one of the key things. How do we want to now synchronize the access token, OAuth access tokens expiry time and the OAM tokens expiry time? So that's one item we definitely need to think through while implementing the solution. But the solution can be implemented, and there are various flavors in which it can be implemented.
Very good, very good. Now this is possibly one for Josh. LDAP is currently used for authentication between learning management systems at my company. What would be the recommended solution to replace LDAP authentication between systems?
Yeah, so that's a good question, and actually a fairly common scenario. So the way that I'm interpreting that question is today between system-to-system calls, maybe you're passing username and password in an HTTP basic header, and that gets passed from app to app, and that can be a very I'm going to say expensive operation, presumably against the LDAP repository because you're passing actual credentials, so that the credential, every time it hits an endpoint, you have to go back to the LDAP and do an authentication. So the recommendation there would be to use the resource owner's grant type. So initially what the client does is it sends a username and password to the OAuth server in exchange for an access token. That access token then can be passed with every request, and then downstream consumers can take that access token and validate it, and they'll still be able to retrieve who the underlying user is and additional information about the user. So for example, a common thing that you might want to do there is that when you're issuing the access token, authenticate the user against LDAP, but also retrieve some key attributes so that they're associated with the token. And the Vordel API server can do that. So my suggestion would be to use resource owner's grant type, integrate it with your LDAP, and move to a model, one of the two-legged flows, to pass access token around.
Great. Here's another one. We're currently evaluating fine-grained authorization tools. How does OAuth work with these tools? Which one of you would like to take that, Nazir?
Yep, I can take that. Yeah, so like I described in the use case, it's very when OAuth authorization are really based on scopes, and the fine-grained entitlement solution is more based on like roles and attribute-based models and all that. So one way of integration, one possible integration which I see is the fine-grained entitlement solution can have its complex policies and all that in place, and can return a grant to deny decision back, and also can return as part of obligations bunch of scopes which are allowed for this user. So what happens in that case is once these scopes are given to the OAuth API server, OAuth sticks to the scope and provides the enforcement of what is allowed to the user. So at runtime, the OAuth server is actually acting as a policy enforcement point and checking the access based on the scopes which was given at the time of token generation by the fine-grained entitlement solution. So the complexity of the fine-grained entitlement solution is not hit hard at runtime on each and every request, right? So those are the things which we have to consider, and that's one of the integration that I can think of when we are trying to integrate OAuth with the fine-grained entitlement solution.
Thanks, Nazir. Here's another one. If the resource approver is not the same as the user, then how is approval obtained? Josh?
Yeah, I mean, I think that's probably the resource. Yeah, so this is one of the kind of obvious outages around the enterprise, around OAuth for enterprise use cases. So it's sort of like I've got a three-legged flow, but at the end of the day, I'm not really authorized to grant access to this resource. So maybe a use case there might be like a bank account where there's like a guardian or something who has to grant the access on my behalf, or any of those sort of delegated scenarios. And so the spec doesn't really cover that or any of these more sort of complex scenarios where you're talking about sort of a chaining of grants and things like that. So I think there's two things. One, in some of the two-legged flows, you can look at things like JWT, which are extensible, and thinking about issuing tokens that have additional attributes that are maybe tokens themselves. So that would be one way to think about it. I think the other thing that would be there, if you had to have a three-legged flow, you could think about introducing a workflow system or something that you could think about, hey, I want access to this resource. Oh, I get kick off a workflow. Somebody else gets notified. The approver says okay, and then you get like an email back that has the actual link that then you, the end user, can push to sort of reconnect the three-legged flow. So I would agree that it's maybe not perfectly defined in the spec, but it's sort of an emerging use case that I think there's some reasonable ways through either JWT or some of your other enterprise technologies like a workflow engine to be able to pull together.
Great. The questions are still coming thick and fast, but we're running out of time, so I'll try and do 2 more questions, folks, and we will get back to you on all the others directly. This one is for Nazir, and I think it flows from a previous response you gave relating to using OAuth with OAM. The question is, can the same OAM cookie swap for an OAuth token be done using a SiteMinder cookie session? Does that make sense to you? Is that clear?
Can you repeat it again?
Yeah, so can the same Oracle Access Manager cookie swap for an OAuth token be done using a SiteMinder cookie SM session?
Oh yeah, yeah. So we can, like, API server has integration with the SiteMinder. When the SiteMinder cookie comes in, there are actually different ways we can get that cookie asserted. Using, like, one way is to use the out-of-box SiteMinder plugin which we have in the API server, which when we pass the SiteMinder cookie to the SiteMinder server, it says that, yeah, the cookie is valid and asserted. That's an assertion getting from the SiteMinder access server, and a token would be generated, OAuth token can be generated out of that and sent back to the user. Yeah.
Great, thanks. Actually, this one I can probably answer myself, and I'll save one, a more difficult one for Josh at the end. The question is really, is there any OAuth sample that we can try in the Vordel Policy Studio? And the answer is that in 7.1 there are out-of-the-box samples. And I mean, some of you have commented on the 2 and the 3-legged model and the various implementation patterns we've outlined here, and that some of them seem more complex than others, and that's obviously the case. But we do run immerse workshops around the globe, and it's an ongoing event that we're hosting in different cities in North America, EMEA, Asia Pac. So be sure to check into the Vordel website on an ongoing basis, and you'll see where we're next hosting events in a city near you, hopefully. And if there isn't one there that you would like to attend in your area, just let us know. Just submit us an email. I guess I'll take the last one for you, Josh. Does Vordel API server support the OAuth exchange flow? In my case, swap a token for a SAML assertion.
Yeah, so swapping a token is the question. Is it SAML assertion in and then OAuth token out, or is it OAuth token in and SAML assertion out? I can talk about both.
Yeah, I think it's the best way to do it because.
Okay.
Yeah.
Perfect. So SAML assertion in to OAuth token is a sort of well-known extension, and we can certainly do that. Now, then the other flow would be if I have an OAuth token and then generating a SAML assertion. For that, we certainly could do that. The API server has robust SAML capabilities. At authentication time, when you're issuing the token, we're able to capture all the sort of necessary information, including additional attributes that could then be easily mapped into the issuing of a SAML assertion. So I think, regardless of the sort of direction of the swapping, we can handle both those use cases.
Great. Okay. Thanks very much, Josh. And folks, we're going to call a halt there. As I say, this will be available on the Vordel website later today, first thing tomorrow morning. And in the meantime, I'd like to remind you to register on the Vordel website as early as you can for the upcoming webinar. And again, thanks very much to Nazir from SENA. Thank you very much, Nazir.
Thank you.
And Josh Bregman from Vordel. Thank you, Josh.
You're very welcome, Hugh.
So, folks, we'll see you online December 6th, hopefully. And with that, the webinar is now finished. Thank you.